Hello everyone, and welcome back to MIS 5000 Special Topics in MIS, aka Python programming and programming logic. In this lesson, we're going to finally introduce the concept of repetition, and more specifically talk about Sentinel-Controlled or indefinite loops. The first concept we're going to visit is that of repetition in programming logic. If you have some coding experience, you may have worked on a problem in which a particular piece of code needed to be repeated several times in order to process several different items or several different variables. And of course, this method will get the job done if you are sure of how many different items you're going to process each time. You can simply copy the code over and over again. However, this isn't very efficient, and it doesn't allow your code to be dynamic. What we want to do is allow a process to be repeated and to encapsulate that process in repetition, or in, as we're going to call it, a loop. More specifically, we're first going to talk about what are called Sentinel-Controlled or indefinite loops. Let's consider the case of the self-checkout system once again. When you are checking out at the grocery store, the task that is being repeated is that of scanning an item and having the price of that item be added to the total price. Keeping a running total is a very common application of a Sentinel-controlled or indefinite loop. The system does not know how many items you're going to scan beforehand. Rather, the system employs what is termed a sentinel that is used to detect when the last item has been scanned. In the case of the self-checkout system, this usually comes in the form of the user pressing the pay button or inserting a payment card. The specifics can vary, but essentially the user is in charge of any repetition happening in the system. This is in contrast to a loop or repetition in which we know beforehand exactly how many times it is going to process, and it terminates after the last time. What we're going to do in this module is start by looking at an application without repetition. Then we are going to use repetition in the form of a Sentinel-controlled loop so that you can see how it is modeled using a flowchart. The learning objectives for this module are as follows. After this module, we would like you to be able to define and explain the purpose of repetition in programming logic, to define the concept of a loop control variable, and explain its role in a Sentinel-controlled loop, to be able to create a flowchart that models the logic of a Sentinel-controlled loop, to identify the most common Sentinel-controlled loop mistakes, and finally to identify the most common applications of Sentinel-controlled loops. The best way to learn about indefinite loops and how they are modeled using flowcharts and later applied in programming language logic is to take a look at some examples. So we're first going to ask ourselves this question. So what are indefinite loops with Sentinel values, and how can we model them using flowcharts? We're going to start with the following example, and the first time we run through this, we are not going to use any repetition. We'll visit that a bit later. We are going to write a flowchart for a bouncer application that asks the user how old they are and tells them either that if they aren't old enough, that they need to grow up, or if they are old enough, that they should join the party. We're going to assume in this case that they need to be at least 21 in order to join the party. Let's go ahead and open up Microsoft Visio. I'm going to begin, as always, by first entering a description for the application. This application asks a user how old they are and tells them either to grow up or to join the party if they are 21 or older. I'm also going to preemptively drag out another square for our legend. Next, I'm going to add our ovals for start and stop terminals. Okay, so here we're simulating a person trying to enter a club. They get up to a bouncer who checks their age and either lets them in or turns them away if they aren't old enough. Again, we're not focused on repetition right now, we're just focused on this conditional logic. Later, we're going to give the user an opportunity to grow up and have the bouncer check again to see if they're old enough to actually enter the club. So the first thing we need to do when we think about this simulation, the user approaches the club and is asked to input their age. So I'm going to grab a parallelogram for our input prompt. So prompt, how old are you? Again, we could just use age and a colon. I'll go ahead and set it up this way. Go ahead and add our flow line connector. And don't forget to include in parentheses a new variable of age to hold that value, because we'll need that in order to actually check to see what the age is in our decision. I'm going to go ahead and add the age to the legend. So age is the age of the user. So this is fairly straightforward. We just need a decision point to check whether or not they are 21 or older or not. So I'm going to go ahead and grab a diamond for our decision. Go ahead and connect it with a flow line. And in the diamond, I'm going to put age is greater than or equal to 21. So we have two options here. We have our dual alternative selection structure. On the right, I'm going to put what happens if this condition is true. On the left, I'm going to put what happens if this condition is false. If it is true, I'm going to provide output to the user that says join the party. And if it is false, I'm going to provide output that says grow up. These are our two possibilities. I'm then going to use a circle to join these different branches back together like so. So remember that each time you have a decision, you'll need to pull both sides together again with a connector. Go ahead and connect that connector to the stop terminal. So this is a really simple application. No repetition, of course. We just simply ask the user how old they are. We check their age to see whether or not it met the condition of being 21 or greater, and provided output based on that result. I'm going to go ahead and save this as basic bouncer, and I'll put this on Blackboard. Okay, so at this point we now have modeled the application where the user is asked how old they are. We then test to see whether or not they are 21 or older and can enter the club. If they are told to join the party. If they are not, they are told to grow up, and the application terminates. At this point, we are going to give the user an opportunity to grow up, and basically that means we're going to prompt them to input their age again. And in order to do this, we're going to have to add repetition in the diagram. Now again, this is going to be an indefinite loop. Indefinite loops run as long as the loop control variable allows them to run. So the first thing I'm going to do is revise the description to add the idea that we're going to give them an opportunity to change their age. So this application asks the user how old they are and tells them either to grow up or to join the party if they are 21 or older. If they are not old enough to join the party, they are given the opportunity to change their age and enter. So again, the indefinite loop, the number of times it runs is determined by the loop control variable, or the Sentinel control variable. In this case, the Sentinel control variable is the user's age. It's actually the only variable that we have. So let me go ahead and remove some of these flow lines and start to talk about where we can put the repetition in. Now in this case, the application still terminates after they are 21 or older and told to join the party. So I can actually leave this branch alone. There's nothing else that needs to be done here. What needs to happen is, so we ask the user how old they are. We're then going to start the loop. If they are not yet 21, they're going to be told to grow up. And then we are actually going to re-prompt them for their age. So let's go ahead and add a flow line here. Actually just going to repeat the prompt that asked them for their age before. Now the question is, where should I connect the flow line to for the repetition? So one common mistake with indefinite loops is not updating that loop control variable. So leaving this prompt out would be the first type of error that I could make if we didn't ask them their age again before we checked to see if they were 21 or older or not. The loop would just keep running indefinitely and it would never terminate. We have solved this problem. We've added a prompt within the loop structure that we're creating to ask them for their age again. So we have fixed that issue. Now we just need to decide where the flow line should return back to in order to create the loop. So what I'm going to say next is very important, and that is that your loop will start, regardless of the type of loop that it is, with the condition. So consider the decision point in the flowchart to be the start of the repetition. So what we're going to do is I'm actually going to get rid of this flow line and move a few things around. I'm going to add another connector up at the top right before the decision point. And then finally, I'm going to take a flow line from the new prompt and return it to that connector. So let's take a look at how our little robot would proceed along this flowchart. We start, we ask the user how old they are. At that point, the loop structure begins. We check to see whether or not their age is greater than or equal to 21. If it is, we output join the party. Notice that we do not at that point enter the loop. We simply exit it, tell them to join the party, and terminate. We go ahead and actually just connect this flow line directly to the input. If they do not meet that criteria, we take the false branch, tell them to grow up, and then, very important, we re-prompt them to enter their age. Again, if I took this piece out, what would happen is if they put in 19, for example, we would take the false branch, it would tell them to grow up, and then it would simply return to the start of the decision point, and it would be false again, and we'd simply keep rerunning the loop over and over again, resulting in what is called an infinite loop. So again, notice that the number of times that the loop runs is controlled by the variable age in this case. So it's important that we first initialize that variable. In this case, we're pulling a value from the user, that we then have a condition that checks to see whether or not we're going to enter the loop or not. And then inside the loop, we have to make sure to actually update that loop control variable. So this is our first example of an indefinite loop as shown in a flowchart. Again, the key components here are that we first initialize the loop control variable outside of the loop, so before the decision point. We then have a termination condition, and within the loop structure, we give the user, in this case, an opportunity to update the loop control variable so that the program and the loop will actually terminate. I'm going to go ahead and save this as bouncer indefinite and put that on Blackboard for you. So now that you've seen an example, let's go ahead and talk about the vocabulary involved in an indefinite loop. So what is a loop control variable? In the example we just saw, the loop control variable was that of age. The value of age determined whether or not the loop was going to run. Let's take a look at this flowchart. So you'll notice this flowchart is a little bit different because it involves some variable declarations. As we are doing Python, we're not going to declare our variables in this way, but bear with me for a moment while we take a look at this. So again, the key to an indefinite loop is that it is performed a different number of times each time the program executes. Okay, so if we take a look at this example, we initialize a variable called should continue. We then ask the user, do you want to continue? Yes or no. We then take input from the user to store a value of either y or n for should continue. This is where the loop control variable is initialized. In our previous example, this occurred when we asked the user for their age. Notice that after the loop control variable is initialized, we then begin our repetition with the decision point. So we check to see if the value of should continue is y. So we test the loop control variable. If it is not y, we take the left branch, we see the output of goodbye, and the program terminates. If should continue has a value of y, we then say hello to the user, and again ask them if they want to continue y or n. This is where we give the user an opportunity to actually alter that loop control variable, which again is very important to avoid creating that infinite loop. If we don't include this input process within the loop repetition, then we will end up with that infinite loop. So if the user then puts in n or anything else, when we check to see if should continue is equal to y again, we will take the left branch and the loop and the program will terminate. So we really need to do three things when we are working with indefinite loops. We have to first initialize the loop control variable. We then test the loop control variable, which is the start of our loop. And then we have to make sure that within the repetition that we either have the user change the value of the loop control variable or that it is changed by some other computer process. Failing to initialize the loop control variable, failing to alter the loop control variable, or failing to test the correct variable will result in the loop not operating in the way that you want it to operate. So to summarize that once more, in a program's mainline logic, 3 steps should occur in every properly functioning loop. First, we have to provide a starting value for the variable that will control the loop. In the previous example that we did in Visio, that was age. We then have to test the loop control variable to determine whether the loop body will execute or not. So in that case, we check to see if age was greater than or equal to 21 or not. And then on the side of the repetition, we have to alter the loop control variable within the loop. Failing to do so will result in an indefinite loop. So there are really 3 areas where one can make a mistake when constructing this kind of loop. So just make sure that as you are constructing your flowcharts that you make sure that you have each of these 3 components. So let's take a look at another example of an indefinite loop. So we're going to create a flowchart for the following application. Write an application so that your computer can play Guess the Number I'm Thinking Of with you. So basic Guess the Number game. The computer should keep asking for a number. If the user's guess matches the computer's number, the computer should congratulate the user and then terminate the program. If it doesn't match, the computer should express sadness and tell the user to keep guessing. So let's think about how this game will actually proceed before we head over to Visio. I know at some point I'm going to have the user actually guess a number. So the user will have to have an opportunity to input a value for their guess. The guess will have to be tested against a number that the computer has. So we also have to keep track of the value of the variable that we are going to use to represent the computer's value. And then at some point, if the guess is wrong, we'll have to give the user an opportunity to make another guess. So you can kind of perhaps see where this is heading, which side the loop will be on, and what the loop control variable should be. So I'm going to go ahead and head over to Visio, bring out a square from my description. This application simulates a number guessing game with a user. If the user guesses the number incorrectly, the computer should express sadness and let them guess again. If the user guesses correctly, the computer should congratulate them and the application should terminate. I'm also going to pull out a square for what will be our legend, and then pull out 2 ovals for our start and stop terminals. Okay, so really 2 things have to happen at the start of this process. The computer has to pick a number. So in order to simulate that, we're basically going to use a process to assign a variable that we use to represent the computer's number a value. So let's go ahead and pull out a rectangle for that process. Going to connect it to the start terminal. And in this case, so we're still using pseudocode, but I'm going to introduce the concept of generating a random number, which we will do later in Python. In this case, I'm going to simply say actual equals random, and I'm going to put 2 parentheses after random to denote a process, to denote a function that generates a random number. So we start the program, the computer picks a random number. So we have to first add that to our legend. So actual will be a random number chosen by the computer. We then have to give the user an opportunity to guess the number. So we're going to use a parallelogram for that. So we'll go ahead and say prompt. We'll keep it simple. I will just simply say guess. And then in parentheses, I'm going to put a lowercase guess to represent that variable. Go ahead and add guess to the legend. So guess is the user's number guess. So again, I'm actually going to start this by not considering repetition. I'm just going to consider what would happen immediately in each case. So let's go ahead and bring out a diamond for our decision. So we are going to test to see whether or not the user's guess is equal to the actual value. So in order to do that, I'm going to say guess, use the double equal sign to ask the question of equality, and include actual. So is the guess equal to the actual value? Now at this point, I encourage you to think about, okay, we have two variables at this point. What is the loop control variable? Is it the computer's number or is it the user's number? So think about which variable we're going to give an opportunity to update in order to determine whether or not we're going to keep running the loop or not. If we change the computer's number, that will make the guessing game extremely difficult. So it's likely that it's not the computer's number. The loop control variable in this case is the user's guess, because it is the value of the guess that determines whether or not we're going to either congratulate them and terminate the loop, or give them an opportunity to guess again and keep running the loop. So let's go ahead and take care of the case where the user guessed correctly. So this is the simpler branch. That guess equals actual is true. We are then going to provide some feedback. So we'll add our parallelogram and say output, congratulations. If we wanted to be a little more clever, we could tell them what the number was, even though they guessed it. Let's go ahead and do that. So congratulations, the number was plus the actual. And I will add another plus and add a period to make it a complete statement. So at this point, this is where the entire program would terminate. So I'm going to go ahead and connect that parallelogram with a flow line to the stop oval. Tidy this up a little bit. Okay, so now we have to consider what happens if guess is not equal to actual. So I'm going to go ahead and first add the left branch, which will be my false branch. The first thing we want to do is express sadness. So we'll use a parallelogram for that. Output, sorry, incorrect. So notice that I don't have any parentheses here. We're just providing general output. I also then have to give them a chance to guess again. Now I do want to point out here, it might be tempting to simply drag an arrow up to the previous prompt. The issue with this is that it is the diamond that is representative of the start of the repetition. So we can't actually do this. So what I'd like to encourage you to do is just to simply add another prompt for the user within the repetition like so, and then to add that connector right before the decision point. I'll go ahead and bring out my circle for that connector. So I'm just going to add a connector here. And then after asking the user to enter a guess again, I'm going to drag that logic back up to the connector that falls right before the decision point. This will allow the user to change their guess so that they might reach the actual value and then receive the message of congratulations and terminate the program. So a couple of things to point out here. First of all, if you compare this flowchart to the previous example, you'll see that they're almost identical. The only real change is that in this case, we added another process in which we were assigning a value to be the computer's actual number. And we did this using pseudocode for a random number generator. But the same rules apply. We first initialize the loop control variable. So again, in this case, the loop control variable is the guess. It is not the actual value. We then test to see whether or not the guess is equal to the actual value. If it is not, we then give an opportunity for that loop control variable to be altered so that the loop will not be infinite and that it will actually terminate. So again, notice that this flowchart is almost identical to the previous flowchart we did. The only difference is that instead of comparing the loop control variable to a constant value, we are comparing it to a random value that we assigned before the start of the repetition. I'll go ahead and upload this one to Blackboard as well. Okay, so let's take a look at another example. In this one, we need a flowchart for the following application. Write an application that rolls a 6-sided die and displays the number on the face of the die as output. The die is rolled until the number 3 is rolled 10 times, after which the number of times each face was rolled is reported and the program terminates. So there are a lot of moving parts here, but I will emphasize that the 3 characteristics of an indefinite loop will still be present in this example. We're going to have to decide what the loop control variable is, how to set up the condition to check to see if it will keep running or if it will terminate, and we'll also have to figure out how to update that loop control variable. So the key here is that we need to count the number of times that a 3 is rolled. So we'll need a variable to represent the number of times the number 3 is rolled. Actually, because we're going to end up reporting the number of times each face was rolled, we will need a variable that keeps track of the number of times each number was rolled. So since it's a 6-sided die, we already have 6 variables, one to keep track of the number of times each face was rolled. We will also likely need a variable to hold the number of the initial die roll. We can do that using the pseudocode for a random number generated again. So this one has a lot more moving parts. There are many more variables involved, but again, I want you to see that the structure, the overall structure for the indefinite loop is exactly the same. So let's go ahead and hop over to Visio. I'm going to call this example dice roll. Grab a square for my description and a square for my legend, and go ahead and set those items up to start. The description, so this application rolls a 6-sided die and displays the number on the face of the die as output. The die is rolled until the number 3 is rolled 10 times, after which the number of times each face was rolled is reported and the program terminates. Go ahead and pull out my 2 ovals for my start and stop terminals. Okay, so let's go ahead and think about how this should proceed. So first, we're going to need the computer to roll a 6-sided die. So in order to do that, we're going to use the concept of random number generation again. I'm going to pull out a rectangle to assign a variable that will hold that initial dice roll. Go ahead and connect this to the start point. So I'm going to call this variable roll and set it equal to, I'm going to again make up a function here, so random between 1 and 6. You can consider this just to be pseudocode that represents the generation of a random number between 1 and 6. We'll get into the syntax details later. Go ahead and add roll to our legend. So roll is a random number between 1 and 6 that represents the roll of the die. Okay, so we've rolled the dice. The next thing that has to happen is we just simply need to display the number on the face of the die as output. So we're just going to take a parallelogram and provide some output. So output, I will keep it simple and just say roll plus the variable roll. So we may revisit this once we put the repetition in. I just want to make you aware of that. But for now, let's start by rolling the die and printing the value of the roll to the screen. Next, I'm actually going to introduce the loop. So I'm going to pull out a diamond for the decision, and the decision is, has the number 3 been rolled 10 times? So at this point, I don't actually have a variable that represents the number of times that the number 3 has been rolled, so I do need to take care of that. Let's go ahead and call that variable 3s, and in the decision, I'm going to check to see whether or not 3s is greater than or equal to the number 10. I'm going to hold off on connecting that flow back to the beginning because I believe that's where the connector is going to come to start the repetition. So similar to the previous 2 examples, if this condition is true, we will take the right branch, which I will label as true, and we will eventually terminate the program. There is a difference here though, and that is that we also need to report the number of times that each face was rolled. So I'm going to grab a parallelogram for that and also start to consider the other variables that I want to introduce. So I probably need a variable that keeps track of the number of times every single number was rolled. So it's a 6-sided die, so we're going to have 6 variables for that. So let's start by writing the output statement. I'm actually going to write 6 separate output statements. So we'll start with 1s. Okay, so as tedious as this is, I made 6 separate output statements, 1 for each variable. So the first statement will report on the number of times that the number 1 was rolled. The second one will report on the number of times that the number 2 was rolled, and so on, for each face of the die 1 through 6. After that, the program will terminate. So I need to go ahead and add all of these new variables to the legend before doing anything else. So you see I have 1s, 2s, 3s, 4s, 5s, and 6s to represent the number of times that each face of the die was rolled. So far I actually have 7 variables. And you should be asking yourself, okay, which is the loop control variable? It might be tempting to say that it is the roll, but in this case, it's actually the number of 3s. So once the number of 3s reaches 10, we go ahead and report on the number of times that each face was rolled and terminate the program. The other note is here that it is tempting to perhaps think that this is actually a definite loop, because you're checking to see how many times the number of 3s was rolled, and when it's 10, you finish. But we really don't know when we're rolling the dice how many times that's going to take. Okay, so we've addressed the true side of the decision. We now need to address what happens if we haven't rolled a 3 10 times yet. So I'm going to go ahead and add the left branch and label it with false. So at this point, I'm thinking to myself, okay, I have the loop control variable, and that is 3s. I am testing to see if 3s is greater than or equal to 10, but as of yet, 3s actually doesn't have a value. I've initialized the roll, but I haven't actually initialized the loop control variable. So when I get to this point in the flowchart, 3s won't have any value, and when it's tested against 10, it will throw an error. So I need to make sure that I'm setting 3s to some initial value. In this case, because I'm counting the number of times each face is rolled, I want to set all 6 of these variables initially to 0. And I want to make sure that I do that before the repetition starts, because if I include the initialization of each variable inside the loop, I'm going to reset them to 0 every single time I re-roll the dice, and I will end up with an infinite loop, not counting anything at all. So I'm going to add to the beginning of the flowchart. I could add this before the roll or after. I'm actually going to choose to add this before the dice roll. I'm going to include it in this rectangle process in the following way. So I'm going to initialize every single one of these variables in this box. So 1s equals 0. So in this process, I have now successfully initialized the loop control variable, which in this case is 3s. I have also rolled the dice, and I've also initialized all of the counters that I have for the other faces of the die. So I've now ensured that I'm not making the mistake of not initializing the loop control variable. Now when I get to this point in the chart, 3s will have the value of 0 initially, so it will take the false branch, and we will proceed from there. So now we take the false branch successfully because we have remembered to initialize 3s. Let's see again what the specification says to make sure we're on the right track. So the die is rolled until the number 3 is rolled 10 times, and then we're going to report the number of times each face was rolled. So within the loop, we have to count the number of times each face was rolled. So in order to do that, we actually are going to end up with a case statement in which we are going to check to see if the roll is equal to 1, 2, 3, 4, 5, or 6. And within each of those cases, we will add 1 to the corresponding face. So let's go ahead and get this process started. So I'm encouraging you to think of this in terms of components. We are sketching out the repetition based on this decision. We've initialized the loop control variable. We are now going to insert a case statement on this side of the decision. So the case structure will be identical to that in the previous module. We're going to have a set of decision points that are connected to one another and do a process if a true branch is taken. So the first of the case statements will be, is roll equal to 1? If it is true, we will update the value of 1s. I'm going to take care of the false branches first. for simplicity, and I'm going to stack them like so, similar to our previous module. It's going to be a little tedious, but I'm going to have 6 separate decisions that test to see if the roll is equal to 1, 2, 3, 4, 5, or 6. Let me go ahead and set that up. So thus far I have set up the false branch for testing to see whether or not the dice rolled a 1, 2, 3, 4, 5, or 6. Because the roll value is controlled by this random number generator, we can assume we will get a value of 1, 2, 3, 4, 5, or 6. So we do not need a default case in this case. So if we didn't roll the 1, we then check to see if we rolled a 2, and so on. On the true side of each decision, we then need to add a process that updates the number of times each face was rolled. Like so. So in the first case, if roll is equal to 1, we are going to say, okay, 1s is equal to 1s plus 1, which I'm actually going to abbreviate in the following way. I'm going to say 1s plus plus. This will be syntax that we use later on. So 1s plus plus represents taking the current value of 1s and adding 1 to it. I'm going to reproduce this process for every true branch. So if we roll a 2, for example, we're going to increase the number of the 2s count by 1, and so on. This point here is actually where we are updating that loop control variable. So this process right here updates the number of 3s we have rolled. I will also add true to each of these branches. Go ahead and take care of the logic first and then come back and label it. So if we rolled a 4, we increase the value of 4s by 1. If we rolled a 5, we increase the number of 5s by 1. And finally, if we rolled a 6, we increase the number of 6s by 1. I need to label each of these right branches as the true branch. Okay, so you can now see the full case structure. I'm going to add connectors on this side to bring all of the logic back together and then add the repetition. So you can see that while there are many more variables in this example, that we still first initialize the loop control variable, in this case 3s. We test the condition, is 3s greater than or equal to 10? If it is true, we exit the loop. If it is false, in this case we have a lot more logic where we check to see which face we rolled and update our counter for each face value accordingly. If we take a look at the specifications again, this application rolls a 6-sided die and displays the number on the face of the die as the output. The die is rolled until the number 3 is rolled 10 times, after which the number of times each face was rolled is reported and the program terminates. We are actually very close to having a complete flowchart, but there are a few items that we need to address. So first, let me finish connecting the case structure in the appropriate way. So you can see at the moment I'm putting in place all of the connectors that appropriately represent the case statement. So I'm using a connector to bring 2 sets of flow lines together each time. At the end, I'm adding the final false branch and connecting the final connector over here. So I have captured the entire case statement on the false side with this piece of the flowchart here up to this point. I can now move from here to the repetition. Let me go ahead and zoom out so you can see what is forming, and I'll zoom in again so you can see the text. And again, I will post a link to this on Blackboard. So I've taken care of increasing the value of each face variable in the appropriate way. So if I rolled a 3, for example, I'll increase the value of 3s. What I need to do now is, because 3s is not yet 10, I need to re-roll the dice and print out the value of the roll again. So here's where I'm going to make a slight change in the order of operations. What I'm going to do is I'm going to actually include the first roll and the output inside the loop. I can do this because the loop control variable is initialized with this 3s statement, so that is actually taken care of before the loop starts. This will also prevent me from having to roll twice. So let's go ahead and take a look at what this will look like. This is a little bit different from the previous examples, but conceptually it is the same. The skeleton is the same. So I'm going to bring up the decision point, and on the false side, I'm going to go ahead and alter this. So initially, remember that threes is set to 0. So if threes is set to 0, I come to this decision point and I automatically take the false branch. So I will enter the loop. Once I've entered the loop, I'm actually going to roll the dice. So I'm going to remove this statement from this process block and instead include it inside of the loop. So we're going to go ahead and first initialize all of the variables to 0. We are then going to immediately enter the loop by testing to see whether or not threes is greater than or equal to 10. It is of course not, because it has a value of 0. From here, we'll actually start our false branch. We will roll the dice, and then we will output the value of the roll. Go ahead and label this false branch. So you can see I've altered this slightly. Again, we start the program, we initialize our 6 counter variables to 0. Doing so allows us to immediately test the loop control variable. So threes is 0. We take the false branch and then roll the dice. We output the value of the roll and then check to see, based on what the roll is, which face variable we have to update. I'm going to go ahead and continue connecting the flow of the logic here. And in this case, after we've completed the roll of the dice, the output of the roll, the case statement that will take care of updating the counter variables, we can then use this connector to connect back to right before the loop starts on this decision. So I'm going to go ahead and grab a connector to put right before the decision starts. Go ahead and connect it to the decision. And then finally connect this connector here all the way up to right before the decision starts. So let me go ahead and zoom out so that you can see the completed flowchart. I realize that the words are hard to see at this level, but again, I'll include a link so that you can see it all together. So let's again take our little robot through the process to make sure that we've taken care of absolutely everything in this application. So we start the program, we initialize all of our counter variables to 0. We then test our loop control variable, so is threes greater than or equal to 10? If it is, we exit and report the number of times each face was rolled. But of course, that's not going to happen the first time. We know in this case that the first thing that's going to happen is we take the false branch, because 0 is certainly not equal to or greater than 10. We then roll the dice, we output the value of the roll, and then test to see what the value of the roll was so that we can update the appropriate counter variable. Once we've done that, we return to our test. When 3 has been rolled 10 times, we will then take the true branch, report on the number of times each face was rolled, and terminate the program. Now, this is certainly the most complicated flowchart that we have attempted up to this point. However, each of the moving parts is actually something that happened in a previous module. So we have the indefinite loop here. The structure actually is exactly the same as our previous indefinite loops. We have all 3 components. We have a case statement, and we also have some processes and input and output. I will go ahead and post this example to Blackboard. So we've now taken a look at several examples of indefinite repetition. Let's summarize some of the common applications of loops. 2 of the most common Sentinel-Controlled loop or indefinite loop applications include input validation. So we had several cases of this, that we asked the user to guess a number, and we ran the application until they guessed the correct number. We also had the user input their age until it was 21 or greater, so that was more input validation. Another very common application of an indefinite loop is that of keeping track of a running total. We saw an example of this in the dice application, where we kept track of a running total of each time we rolled a specific face. So we rolled the dice, we added the current roll value to the total until the loop terminated. So again, input validation and keeping track of our running total are the most common applications of indefinite loops. So the last thing we need to do is discuss the most common loop mistakes. So we have 3 items that we need to absolutely take care of when we are setting up an indefinite loop. And as it turns out, there are 3 corresponding mistakes that we can make when setting each of those components up. So the first type of mistake is that of failing to initialize the loop control variable. So in the case of having the user guess the computer's number, we never initially ask the user to guess a number, and thus we fail to initialize the loop control variable. In the case of the dice roll program, if we did not first set the value of 3s to 0, the test of 3s is greater than or equal to 10 would throw an error and the program would not work properly. So that is the first type of mistake. The second type of mistake has to do with failing to alter the loop control variable. So in the case of the bouncer program, if the person was not 21 or older, we entered the loop and then we did not give them an opportunity to increase their age. Doing so would result in an infinite loop. So we had to make sure that we included another prompt to have them re-enter their age so that the loop could terminate. The last mistake has to do with testing the loop control variable. So when you are setting up the decision that tests the loop control variable, you need to make sure that you do that properly. When you only have one variable to work with, so for example in the bouncer program we were only testing the age, it's quite simple to set up that test. However, if you have many additional variables, like in the example of the dice program, it may not be clear how to set it up properly. In our case, we needed to set it up so that we were testing to see if the number of 3s rolled was greater than or equal to 10. One of the mistakes we could have made would have been setting it up to test if roll was greater than or equal to 10, for example, or really any of the other variables. Failing to set up that decision correctly can result also in an infinite loop, or in simply a program that doesn't function the way that you want it to. This concludes the introduction to indefinite loops in flowcharts. I highly encourage you to work through each of the examples on your own if you can, and let me know if you have any questions.